Welcome to the Understanding How Confidential Data is Being Used module of the Symantec Data Loss Prevention 15.5 Administration course. There are many opportunities for an organization's confidential data to be compromised or misused, either intentionally or inadvertently. Such occurrences can be as simple and innocent as an employee accidentally copying an unauthorized person on a group email that contains restricted information, or as premeditated as someone trying to transfer company secrets to a competitor for personal gain. Additionally, privacy laws vary from country to country, so an employee of a multinational corporation who visits a foreign office might not be adequately informed about what data is allowed to leave the country. If that employee unknowingly sends confidential data outside of the country, they may be exposing their company to legal problems. Organizations need to strike a balance between making confidential data available to those who need access to serve customers and support business operations, and preventing confidential data from falling into the wrong hands. To help achieve this balance, it is critical to identify how confidential data is being used within the organization. In the context of the data loss risk reduction implementation model described in a previous module of this course, this is accomplished during the baseline phase, where the focus is on gathering data, understanding where the organization's risk is, and tuning policies and procedures in preparation for taking action in later phases. Symantec DLP's Network Monitor, Network Prevent, Cloud Service for Email, and Endpoint Prevent are valuable tools in helping establish this baseline. The business objective for this module is to understand how confidential data is being used, and this module will cover the following topics: monitoring confidential data as it moves across the network, and monitoring confidential data as it's being used on endpoint computers. Monitoring confidential data moving across the network. In this topic, we'll discuss the functions of Network Monitor, Network Prevent for Email, Network Prevent for Web, and Cloud Service for Email, and how to configure these products to monitor how confidential data is being used in an organization. Symantec DLP's Network Monitor, Network Prevent, and Cloud Service for Email enable DLP administrators to determine how confidential data is being used in an organization and how to prevent it from being compromised. They enable organizations to monitor data leaving the organization in order to protect intellectual property, demonstrate compliance, and safeguard their brand and reputation. Network Monitor, Network Prevent, and Cloud Service for Email complement each other when used together. Network Prevent adds the capability of automatic blocking. Network Monitor covers protocols that are not handled by Network Prevent, and Cloud Service for Email monitors and protects data leaving an organization through Microsoft and Google Cloud Email Services. Network Monitor and Network Prevent typically reside at the network egress points in the DMZ, while Cloud Service for Email is hosted in the Symantec Cloud. Note that Symantec DLP Cloud Detection Service, through its integrations with Symantec CloudSoc and Symantec Web Security Service, can cover some cloud data in motion use cases. For more information about Cloud Detection Service, see the modules Overview of Symantec Data Loss Prevention, Identifying and Describing Confidential Data, and Enhancing Data Loss Prevention with Integrations within this course. Network Monitor scans data leaving an organization to see if it contains sensitive information. Most customers use Network Monitor across multiple protocols to ensure broad coverage of data loss threats. Network Monitor captures and analyzes traffic leaving the network. It detects confidential data and significant traffic metadata over protocols you specify, for instance SMTP, FTP, and HTTP protocols, over both IP4 and IP6 network packets. You can configure a Network Monitor server to monitor custom protocols and to use a variety of filters per protocol to filter out low-risk traffic. Using Network Monitor helps organizations establish a baseline for what data is being transmitted over common protocols and custom protocols. This baseline enables organizations to take appropriate measures, such as training employees about data security or addressing broken business processes, as well as fine-tune DLP policies before implementing notification and blocking actions. After the data usage baseline has been established, you can turn off Network Monitor and use Symantec DLP's network and cloud technologies to enforce your DLP policies. Then periodically, you can turn Network Monitor back on to verify that your policies are catching all instances of data loss in your organization, and to further fine-tune policy rules as needed. Network Monitor is typically configured to inspect traffic with the greatest potential for confidential data loss. At a typical data center, there is a substantial amount of low-threat traffic, such as UDP or secure VPN traffic, as well as inbound traffic intertwined with a high-threat traffic, such as SMTP, HTTP, FTP, and instant messaging. In a standard deployment, Network Monitor is configured to filter out low-threat traffic to ensure that CPU cycles are not spent processing low-risk data. Data that can be eliminated from analysis includes encrypted traffic, streamed media, or low-risk automated administration services, such as IM keep-alives. Narrowing down inspected network traffic to the highest risk communications is accomplished by configuring filters for IP networks and addresses, application layer senders and recipients, and arbitrary name-value pairs and headers. You can configure a Network Monitor server to monitor custom protocols and to use a variety of filters per protocol to filter out low-risk traffic. Typically, the Network Monitor server is deployed in the DMZ, the demilitarized zone, but this is not a requirement. There are a few ways to provide Network Monitor with a copy of network traffic: port mirroring, switched port analyzer or SPAN, network tap, or an encrypted traffic management ETM solution. When you use port mirroring, the network packets coming into or going out of a switch's port are copied to another dedicated switch port that is connected to the Network Monitor server. Port mirroring requires a network switch that includes this feature and is a viable option for networks with lower levels of traffic, less than 1 gigabit per second. When you use a network tap, all network traffic passes through the tap, and the tap sends copies of every packet to the 2 monitor ports of the Network Monitor server. The tap method separates inbound and outbound traffic, so that traffic can be reassembled for analysis without corruption. Using a tap with Network Monitor is the recommended approach for networks with higher levels of traffic, that is, 1 gigabit per second and higher. When you attach the Network Monitor server to a copy port on an encrypted traffic management or ETM solution, such as Symantec SSL Visibility Appliance, SSLVA, Network Monitor will see a copy of all network traffic, including any encrypted traffic that is decrypted according to ETM policy. There are several prerequisites that must be met before a Network Monitor server can be added to a Symantec DLP environment. Number 1. Install a valid license for Network Monitor in the Enforce Server Administration Console. 2. If you are using a Windows server to host Network Monitor and want to use an NIC on the server to capture packets, you must install WinPCAP 4.1.3 or later on the Windows host. 3. If you are using an NIC on the Network Monitor server to capture packets, disable checksum offloading for the NIC. Certain checksum algorithms work by modifying network packets and adding empty checksums. Empty checksums can cause network capture drivers to drop the packets, in which case they will not be evaluated by Network Monitor. 4. If you are using a Napatech or Endace card on the Network Monitor server to capture packets, verify that the device's drivers are updated. 5. Set the packet capture device, the NIC or the Napatech or Endace card, on the Network Monitor server to operate in promiscuous mode, so that all inbound and outbound traffic is relayed through this port. 6. Install the Java runtime environment and detection server software on the server where you want to deploy Network Monitor. First, log into the server as administrator. Then, copy the Java runtime environment and detection server installation files, called serverjre.msi and detection server MSI for Windows hosts, and serverjre.zip and detection server.zip for Linux hosts. Copy from your DLP download folder to the server. Next, if you are installing Network Monitor on a Windows server, double-click the serverjre.msi file and complete the installation wizard, accepting all the defaults. Then double-click the detection server.msi file and complete the installation wizard. For more details on the Windows installation process, refer to the Symantec Data Loss Prevention 15.5 installation guide for Windows. If you are installing Network Monitor on a Linux server, please refer to the Symantec Data Loss Prevention 15.5 installation guide for Linux for detailed installation instructions. After these prerequisites have been met, add a Network Monitor server as follows. Step 1. In the Enforce Server Administration Console, navigate to System, Servers and Detectors, Overview. Then click Add Server. From the drop-down list, select Software Server, then select Network Monitor and click Next. Enter a descriptive name for the Network Monitor server, specify its IP address, and leave the port value set to 8100, unless you need to use a different port for Enforce and Network Monitor server communications. When finished, click Save. After a network monitor server has been added to the DLP environment, you can make the following configuration changes to it: selecting network interfaces to monitor, selecting protocols to monitor, configuring traffic filters, IP filters and L7 filters, as well as adjusting the inspection content size. These settings are accessible in the Enforce Server Administration console at System, Servers and Detectors, Overview, the name of the network monitor server, Configure. To select network interfaces to monitor, first select the network interface on the network monitor server through which traffic will be monitored. This is the network monitor server's connection to your packet capture device, that is, a Napatech or Endace card installed in the network monitor server, or a SPAN or network tap. Note that the Network Interfaces option is not displayed until after you have added and saved the network monitor server in the Enforce Administration console. When you return to the server configuration page, Enforce communicates with the network monitor server, detects the available network interfaces, and displays them on the configuration page. To use Napatech or Endace cards with Network Monitor, there are items you must configure in the Network Monitor server's advanced settings in order for these cards to appear in the Network Interfaces list. These advanced settings can be found at System, Servers and Detectors, Overview, the name of your Network Monitor server, Server Settings. The required settings are shown here on this slide. Note that these settings assume that you have already met the pre-configuration requirements for Napatech cards, including the installation of the Napatech tools. For more details related to these prerequisites, please refer to the Symantec Knowledge Base article, Napatech Card Installation, found at the support.symantec.com website. Note also that as of DLP 14.0, Endace on Windows is no longer supported. Currently, only Endace cards on Linux are supported by Symantec DLP. Next, in the bottom section of the Packet Capture tab, select the protocols you want Network Monitor to examine. The list of protocols that Symantec DLP recognizes are based on either protocol signature or the port over which network traffic travels. Network Monitor is port agnostic and identifies application-level network traffic based on protocol signatures to enforce policies even when traffic is leaving from a non-native port. For instance, traffic that is not using standard TCP port 80 is still analyzed and classified as HTTP as long as the format of the TCP connection matches the HTTP protocol signature. System-configured protocols for which recognition is based on protocol signatures are SMTP, HTTP, FTP, and NNTP. In addition to the system-configured protocols, Symantec DLP enables you to add custom TCP protocols. For these customized protocols, Symantec DLP uses port-based recognition only. Protocols are added in the Enforce Administration console at System, Settings, Protocols. You can also make global changes to the built-in system protocols such as SMTP, HTTP, etc. on the Protocols page. When making changes at this level, the Low Ports Monitored field is displayed on the Configure Protocol page. Enter port numbers lower than 1024 that you wish to monitor. Note that ports lower than 1024 are not monitored if you do not specify them for at least one protocol. By default, all traffic on ports equal to or greater than 1024 are monitored. Protocols are recognized and processed based on the order you specify in the Processing Order column. This practice restricts the amount of traffic that passes through the system. Filtering network traffic enables you to specify details about the traffic you want Symantec DLP to ignore in order to reduce the load on DLP servers, improve system performance, and reduce false positives and false negatives in content detection. Filtering also enables you to monitor specific types of data your organization considers important, rather than monitoring and inspecting all traffic that crosses the network. Filtering out unimportant traffic increases network monitor's efficiency. You should design your traffic filters to focus on outbound traffic first, and then determine if inbound monitoring is needed. You should also remove irrelevant or unimportant traffic by eliminating lower priority protocols, identifying IP source and destination addresses, where both IP4 and IP6 addresses are supported, including or excluding L7 senders or recipients, and setting rule-based exceptions at the policy level. Filters can be applied to any monitored protocol. They can be applied globally across all detection servers from the System, Settings, Protocols page, or they can be applied locally to a specific detection server, thus overriding global filters, by accessing the detection server's configuration page at System, Servers and Detectors, Overview, the name of the detection server, Configure, and then clicking the protocol to which you want to add filters. As a general rule, use IP filtering at the monitor or local level rather than at the global level. Global filters do not usually work well for large deployments because organizations in this category might have detection servers scattered across different networks, monitoring different groups of outbound traffic. In such cases, global filters almost never accommodate all of the possible filter conditions these organizations might need to implement. For filter changes to take effect, you must restart certain Symantec DLP services. If filters were applied globally, you must restart the Enforce server's Symantec DLP Manager service. If filters were applied locally, you must restart the Network Monitor server's Symantec DLP Detection Server service. This illustration depicts the points between the flow of raw network data and the detection of content by Symantec DLP, where traffic filters can be applied. The earlier in this flow you can filter out irrelevant traffic, the better. Signature and port filtering are used to include only traffic for specified signatures or ports. As mentioned earlier, Symantec DLP monitors all traffic on ports greater than or equal to 1024, but does not monitor ports less than 1024 if they are not explicitly specified. When you select protocols with low port settings on a detection server, Symantec DLP monitors those ports for traffic. IP-based filtering filters out unwanted traffic based on IP addressing. Traffic can be included or excluded for monitoring for a given protocol by designating IP addresses or ranges. Sampling is the number out of each 10,000 messages you want to monitor as a representative sampling. For example, if you enter a value of 10,000 in the sampling processed out of 10,000 field on the Configure Protocol page in Enforce, Symantec DLP will search every message in this protocol. If you enter 200, it will search 200 out of every 10,000 messages. Organizations might use sampling to determine if a specific protocol warrants monitoring. Layer 7 or L7 filtering is also known as application-based filtering. L7 filters can include or exclude monitoring based on sender or recipient. This means you can use filters to inspect or ignore messages from specific senders or to specific recipients. Finally, during detection, policy exceptions can effectively filter out content before the detection rules are applied. The IP filter is an ordered list of instructions. Both IP4 and IP6 address formats are supported. The filter syntax is plus or minus, comma, destination subnet, comma, source subnet, where plus means keep or monitor the message, and a minus means exclude or ignore the message. Each filter rule is separated by a semicolon. For instance, the first rule listed in this diagram monitors all traffic originating in the 10.1.0.0/16 subnet going out to anywhere, where the asterisk wildcard means any, and then it excludes all other traffic. If you use the include filter, the plus, you must complete your filter with minus star star so that all other traffic is excluded. The equivalent filter in IP6 format is shown in the second line. Note that the /16 subnet mask in IP4 applies to the first 16 bits, leaving the remaining 16 bits for host addresses. This is similar with the IP6/112 subnet mask that applies to the first 112 bits, leaving the last 16 bits for host addresses. To illustrate how IP filters can be used, consider the following scenario. Simplified Healthcare Hospital wants to include all the traffic from their 16.135.0.0/16 organizational subnet and exclude all other traffic. Based on the formatting rules for filters discussed earlier, how would this filter be created? In this case, the filters would be formatted as shown in the lower right of this diagram in both IP4 and IP6 formats. The result of this filter is that traffic with a source IP of 16.135.22.10 would match this filter and be kept for monitoring because it is in the specified subnet, whereas traffic with a source IP of 45.207.139.29 would not match and would be discarded. Now consider a second scenario. The same hospital wants to include all the traffic from their 16.135.0.0/16 organizational subnet, except for traffic from a web server at 16.135.22.5. With this requirement, what would the format of the filter be? The answer would be the filters shown at the lower right of this diagram in both IP4 and IP6 formats. As a result of this filter, traffic with a source IP of 16.135.22.5 is discarded, but traffic with a source IP of 16.135.22.10 is kept, and traffic that starts with a source IP of 23.127 would be discarded. L7 filtering is used to include or exclude, meaning to inspect or ignore, messages from specific senders or to specific recipients. In cases where there are conflicts between sender and recipient filters, for instance, if the sender filter for a particular message evaluates as inspect and the recipient filter evaluates as ignore, the resulting message is ignored. You can add the following symbols to modify sender or recipient filters. The plus sign keeps matching messages for inspection. The minus sign excludes matching messages from inspection. The asterisk added to the end ignores any message that does not explicitly match any of the filter masks. Note that the order in which filters are evaluated is from left to right, and wildcards can be used anywhere in the filter string. Symantec DLP allows you to combine different filtering methods. There are times where you need to combine both IP and L7 filtering to filter traffic appropriately. To combine filtering methods, simply build out both filters for the same protocol. The shown example in this slide shows an IP filter combined with an L7 sender filter that excludes outbound messages from postmaster@simplifiedhc.com, but includes all other outbound messages from the simplifiedhc.com domain, as well as the outlook.com domain. Additionally, there is an L7 recipient filter that excludes all messages addressed to recipients in the simplifiedhc.com and trustedpartner.net domains. On the Detection tab, you can quickly and easily increase a detection server's inspection content size limit, which enables the server to inspect files larger than the default 30 megabyte size limit. Although the ability to increase this limit was available in previous versions of Symantec DLP, it required the DLP administrator to manually adjust an assortment of advanced settings for the detection server. With the inspection content size feature, now you just drag the slider control to the desired size, and Symantec DLP automatically adjusts the relevant advanced settings for you. Immediately after you add a new detection server, you'll notice that the inspection content size customized settings option is not selectable. You must wait until the detection server has fully started and Symantec DLP has determined how much system memory is available on the server. The available inspection content size settings are the default 30 megabytes, 100 megabytes, 150 megabytes, 500 megabytes, or 2 gigabytes. However, the settings you can actually select will depend on first, the number of message chains and the message chain cache size, and secondly, the amount of system memory in the detection server. To enable larger inspection content size settings, you can do either of the following options. For option 1, you can reduce the values of the detection server's messagechain.numChains and messagechain.cacheSize advanced settings. You can find these settings at System, Servers and Detectors, Overview, the name of the detection server, Server Settings. If the detection server has a hyperthreaded CPU, the messagechain.numChains value should be set no higher than twice the number of physical cores of the CPU. For detection servers without hyperthreading, the value should be equal to the number of the CPU's physical cores. For the messagechain.cacheSize setting, Symantec recommends that you set this value to the same number you specify for the messagechain.numChain setting. For option 2, you can increase the detection server's system memory based on the guidance shown in this table. Note that the guidelines in this table may not work for detection servers with profiles or indexes. Refer to the System Requirements and Recommendations section in the Symantec DLP System Requirements Guide for additional sizing guidelines for various profile types. If you need more assistance in tuning your Symantec DLP environment to scan large files, please reference the publication's Symantec Data Loss Prevention Guidelines for Tuning Large Files, available on the Symantec Support website. After you have modified settings related to inspection content size, you must restart the detection server for the changes to take effect. Note that inspecting larger files will take more time, and also the timeout limits will increase, so the detection engine will take longer to time out in the event of detection failures. Also note that if you choose an inspection content size setting of 500 megabytes or greater, Symantec recommends that you enable external storage for incident attachments. For more instructions on enabling external storage for incident attachments during installation or upgrade, please refer to the Symantec Data Loss Prevention Installation Guide and the Symantec Data Loss Prevention Upgrade Guide. For details on enabling external storage for incident attachments after installation or upgrade, please refer to the Symantec Data Loss Prevention System Maintenance Guide. All of these documents are available for download on the Symantec support website. Enforce provides network traffic details on the amount of data captured, files inspected, incidents created, and unprocessed files. This information is provided in a graphical format over configurable periods to enable organizations to perform troubleshooting analysis and capacity management for their various Symantec server products. A huge spike or a sharp drop in the chart can indicate problems. You can access this traffic report at System, Servers and Detectors, Traffic. Clicking the detection server name takes you to a more detailed report. For network monitor servers, this detailed report breaks the traffic down into a report for each protocol that is enabled in the system. Symantec DLP is sometimes forced to discard packet copies before it can analyze them, for instance when there is a dramatic spike in traffic. The traffic report details include an errors entry that shows the number of copied packets that have been discarded. You can use filters to reduce the number of discarded packets. If you see a spike in discarded packets, click the View drop-down near the top right of the report and select the shortest time period during which the spike is still visible. For instance, if the spike occurred today, set the view time period to today. If a spike in discarded packets corresponds with a spike in traffic over one or more of the protocols handled by the network monitor server, it probably indicates that Symantec DLP was not able to process all the traffic moving over the protocols at that time. In this case, Symantec recommends that you use IP filters to filter out some of the traffic over those relevant protocols. Packet capture can generally handle 2,000 messages or more per second indefinitely. If the traffic increases to 10,000 messages per second for a sustained burst, some packets may be discarded due to memory constraints. The messages described here may or may not be filtered out later by L7 filters or for other reasons. If you notice a trend of many discarded packets in your traffic reports, even after you have fine-tuned IP and L7 filtering, you should consider scaling up your Symantec DLP infrastructure. A single Windows-based network monitor server can accommodate network traffic up to 300 megabits per second, and a Linux-based network monitor server can accommodate up to 650 megabits per second. As network traffic volumes increase beyond these levels, you can add dedicated packet capture hardware to your network monitor server, such as a Napatech card for Windows and Linux servers, or an Endace card for Linux servers. These devices are capable of capturing network traffic at volumes up to 1 gigabit per second. To use Napatech and Endace cards with Symantec DLP, you must install the necessary drivers and configure Symantec DLP to use the devices. For detailed instructions on these topics, refer to the Symantec Data Loss Prevention Administration Guide. When network traffic exceeds 1 gigabit per second, the first step you should take is to filter out all traffic that is unreadable to Symantec DLP, such as all voice over IP traffic, UDP traffic, and so on. If traffic still exceeds 1 gigabit per second after filtering, there are other options for upscaling your environment to handle the high volume. 1. Deploy multiple network monitor servers and connect each to a separate span or network tap. Each span or tap should be capturing different network traffic than the other spans or taps. Dedicate each network monitor server to monitor a single protocol. For example, focus one network monitor server on handling all SMTP traffic, another on handling all HTTP traffic, and so on. Option 2, for networks with 10 gigabits per second or higher bandwidth, add a multi-gigabit tap to split out traffic to multiple network monitor servers. When Symantec DLP detects confidential data leaving an organization's network that violates policy, it captures incidents which contain details about the occurrence. For Network Monitor and the other Symantec DLP servers that deal with data in motion, such as Network Prevent servers and Cloud Service, incidents can be viewed in the Enforce Administration Console at Incidents Network. The most recent incidents are listed in the Incidents New report. To view incident snapshot details, click an incident in the report. Some of the details specific to data in motion incidents are protocol, the protocol used to send the data, such as SMTP, HTTP, FTP, NNTP, etc., sender and recipient, the email addresses of the user who sent the message and the individual to whom the message was sent. source IP and destination IP, the normalized IP addresses of the message sender and the message recipient respectively, attachments, the file names of message attachments in which confidential information was detected. Links to open the original files are also included, provided there were no response rules configured to discard the files. Lastly, message body. Although this incident details section is displayed in other incident types as well, for instance data at rest incidents, it is only populated in incidents related to data in motion. It displays the header and body of the message that triggered the incident, and provides a link to open the original message in the default mail client. Although the main purpose of Network Prevent for Web is to stop confidential information from leaving an organization's network via HTTP, HTTPS, and FTP, it can also be used to monitor web traffic without blocking content. Using Network Prevent for Web in this way helps organizations establish a baseline for what data is being transmitted over the web. There are two methods for using Network Prevent for Web to monitor HTTP, HTTPS, and FTP traffic. Method number 1, configure DLP policies to detect confidential information but do not add response rules to the policies. In effect, this causes Network Prevent for Web to run in audit mode, enabling it to detect web traffic incidents without performing any blocking actions. Method number 2 is to configure DLP policies complete with response rules and use the Network Prevent for Web's server's trial mode. With trial mode enabled, Network Prevent for Web detects incidents and reports that it has blocked a communication, but does not actually block the communication. To enable trial mode, in the Enforce Administration console, navigate to System, Servers and Detectors, Overview, and then click the Network Prevent for Web server. Click Configure, and on the ICAP tab, select Trial Mode. To use Network Prevent for Web to monitor HTTPS traffic, you must configure your web proxy server to pass unencrypted web traffic to the Network Prevent for Web server. To configure your web proxy server to forward web traffic to the Network Prevent for Web server, verify that you are using a web proxy server that Network Prevent for Web supports. A list of supported proxy servers is provided in the Symantec Data Loss Prevention System Requirements and Compatibility Guide. Secondly, configure the proxy server's request and response mode services. Exactly how you do this will vary from one product to another, so you may need to refer to your proxy server documentation for details. Some of the general guidelines for configuring these services are shown here on this slide. Note that specifying the port number is optional if the Network Prevent for Web server is configured to listen on the default ICAP port 1344. The main purpose of Network Prevent for Email is to stop confidential information from leaving an organization's network via email. Network Prevent for Email can block emails outright or modify emails to trigger downstream processing, such as quarantine or enforced encryption. However, Network Prevent for Email can also be used to only monitor email traffic without enforcing policies. This approach enables organizations to establish a baseline for what data is being transmitted via email. There are two methods for using Network Prevent for Email to monitor SMTP traffic. 1. Configure DLP policies to detect confidential information but do not add response rules to the policies. In effect, this causes Network Prevent for Email to run in audit mode, enabling it to detect SMTP traffic incidents without performing any blocking actions. Or secondly, configure DLP policies complete with response rules and use the Network Prevent for Email server's trial mode. With trial mode enabled, Network Prevent for Email detects incidents and reports that it has blocked a communication, but it does not actually block the communication. To enable trial mode, in the Enforce Administration console, navigate to System, Servers and Detectors, Overview, and then click the Network Prevent for Email server. Click Configure, and in the Inline SMTP tab, select Trial Mode. Note that Network Prevent for Email cannot monitor encrypted SMTP traffic. Therefore, you must configure your Mail Transfer Agent (MTA) server to pass unencrypted SMTP traffic to the Network Prevent for Email server. To configure Network Prevent for Email server to monitor SMTP traffic, perform the following. Step 1. In the Enforce Administration console, navigate to System, Servers and Detectors, Overview, and then click the Network Prevent for Email server. 2. Click Configure. 3. In the next Hop Configuration section, choose whether to use Reflect Mode or Forward Mode with the MTA. Select Reflect Mode if you want the Network Prevent for Email server to return all emails it has monitored to the upstream MTA from which it received it. The upstream MTA must be able to determine whether an email is coming from the mail server or previous hop MTA, or if it is being returned from the Network Prevent for Email server. To ensure that Symantec DLP analyzes all incoming email, configure the MTA to route email coming from the previous hop to the Network Prevent for Email server, and then to route emails returned from the Network Prevent for Email server to the next hop or to the Internet. Select Forward Mode if you want the Network Prevent for Email server to forward all emails it monitors to a downstream MTA or hosted email provider instead of back to the upstream MTA from which it received the emails. If you select this mode, you must do one of the following. 1. Select the Enable MX Lookup option and specify one or more domain names so Network Prevent for Email can obtain mail exchange records and determine the address of the next hop MTA. Or 2. Select Disable MX Lookup and specify the exact host names or IP addresses of the next hop MTAs. For more detailed information on MTA configuration options, refer to the Symantec Data Loss Prevention MTA Integration Guide for Network Prevent for Email. After you have saved your changes to the Network Prevent for Email server configuration, as in the previous slide, click Server Settings, and then make the following changes to the Network Prevent for Email server settings. Step 1. Set the request_processor.add_default header to false. By default, Network Prevent for Email server uses a header to identify all email messages that it has processed. The header and value are specified in the request_processor.default_pass header field. When using Network Prevent for Email to only monitor SMTP traffic, change the value of this field to false so that the emails are not modified. Number 2, request_processor.default_pass header. This field specifies the header and value that Network Prevent for Email server adds to each email message that it processes. The default header and value is XC filter loop reflected. When using Network Prevent for Email to only monitor SMTP traffic, change the value of this field to false. Third, request_processor.mta resubmit port. Ensure that this value matches the number of the SMTP listener port on the upstream MTA to which the Network Prevent for Email server returns mail. The default port is 10026. Fourth, the request_processor.server_socket port. Ensure that this value matches the number of the SMTP listener port to which the upstream MTA sends email messages. The default port is 10025. Note that many Linux systems restrict ports below 1024 to root access. Network Prevent for Email cannot bind to these restricted ports. If Network Prevent for Email is installed on a Linux computer and it receives mail for inspection on a restricted port, for instance port 25, use the IP tables command to route traffic from the restricted port to the non-restricted Network Prevent for Email port, which is port 10025 by default. For more details, see Configuring Linux IP tables to reroute traffic from a restricted port in the Symantec DLP Administration Guide. Once you have finished with these settings, save your changes to the Network Prevent for Email server settings and click Done. Network Prevent for Email supports inspection and forwarding of TLS encrypted messages. TLS is used with a downstream MTA only when the upstream MTA requests a TLS connection using the start TLS command, and the downstream MTA or hosted email service supports TLS and can authenticate itself. These conditions also apply when Network Prevent for Email operates in reflecting mode, where a single MTA acts as both the upstream and downstream MTA. When TLS is requested, each successive proxy in the email chain must authenticate itself to the previous server to establish an end-to-end TLS connection. Successful authentication requires that each mail server store a valid certificate for the next hop mail server in its trust store. For example, Network Prevent for Email server must authenticate itself to the sending MTA, and the downstream MTA or hosted email service must authenticate itself to Network Prevent for Email server. For details on configuring keys and certificates for TLS, refer to the Symantec Data Loss Prevention MTA Integration Guide for Network Prevent for Email. Symantec DLP Cloud Service for Email monitors and analyzes outbound email from Microsoft Office 365 and Google G Suite Gmail, and can block, redirect, modify, or encrypt email messages. Cloud service for email is centered around one or more detector servers in the Symantec cloud that communicates with your on-premise Enforce server to pull across DLP policies and to send incident information back to Enforce for review and remediation. Cloud service for email integrates with Symantec Email Security.cloud for email delivery and for inbound and outbound email security services. Using cloud service for email to monitor emails from Microsoft Office 365 and Google G Suite Gmail enables organizations to establish a baseline for the data that users are transmitting over their email as a service accounts. Unlike Network Prevent for web and Network Prevent for email, Cloud Service for email does not offer a trial mode. Consequently, to perform monitoring with Cloud Service for email, simply do not add response rules to the policies that Cloud Service for email will use. In effect, this causes those policies to run in audit mode. In this configuration, Cloud Service for email sends incidents to Enforce, but does not block or perform any other action on emails that violate policy. In summary, Symantec DLP's Network Monitor, Network Prevent, and Cloud Service for email enable organizations to determine how confidential data is being used so they can protect it more effectively. Network Monitor captures and analyzes network data leaving an organization to see if it contains sensitive information. Network Monitor can be used across multiple protocols, such as SMTP, FTP, HTTP, and custom protocols. Network Prevent for web can be used to monitor HTTP, HTTPS, and FTP traffic to help organizations establish a baseline for what data is being transmitted over the web so appropriate measures can be taken, and DLP policies can be fine-tuned to more effectively meet organizations' data protection needs. Network Prevent for email can be used to monitor email traffic to establish a baseline for what data is being transmitted via email. Cloud Service for email can be used to monitor outbound email from Microsoft Office 365 and Google G Suite Gmail to establish a baseline for the data that users are transmitting over their email as a service accounts. Monitoring confidential data being used on endpoint computers. In this topic, we'll discuss the function of Symantec DLP Endpoint and how to configure it to monitor how confidential data is being used on employees' laptops and workstations. Symantec DLP Endpoint Prevent uses an agent installed on endpoint computers to monitor usage of confidential data on these devices and prevent the data from being any of the following: accessed by local applications such as Microsoft Outlook, Cisco Jabber, Skype, Google Chrome, and Mozilla Firefox, or any other application you specify, or transferred to cloud storage and shared applications such as WebDAV shares, Box, Dropbox, iCloud, OneDrive, or SharePoint, or burned to CD or DVD, or transferred to removable storage devices such as smartphones, tablets, digital cameras, and portable media players, or copied to or from network shares, or copied or pasted between applications using the clipboard. Note that copy and paste actions are fully supported on Windows endpoints, but on Mac endpoints only paste actions to specific applications such as Firefox, Chrome, Safari, Jabber, and Skype are supported. It can also prevent data from being printed or faxed, or transferred over supported protocols such as SMTP, HTTP or HTTPS, and FTP. The DLP agent monitors activity on the endpoint for policy violations. If there is a violation, response rules are initiated locally. Even if the user's computer is disconnected from the network, the agent will still perform detection and incident response. The incident data is encrypted and written to disk regardless of whether there is a connection to an endpoint server. When a connection is available, the agent sends incident data and extracted text from detected files to the endpoint server for additional detection if needed. The endpoint server sends all incident data to the Enforce server, and the Enforce server stores incident data, initiates additional response rules, and displays the incident in the user interface. Symantec DLP's endpoint features offer considerable flexibility and scalability in monitoring data usage on endpoint computers. The DLP agent is compact and stable, and the endpoint server is designed to accommodate large numbers of DLP agents, enabling the DLP administrator to throttle bandwidth usage between agent and server as needed. You can take advantage of the endpoint environment scalability to improve performance and reliability. You can set up multiple endpoint servers on your LAN and in the DMZ, as well as add load balancers to help distribute endpoint traffic from users' computers both on local networks and the internet. Defining multiple endpoint servers has a couple key advantages. One, redundancy, in cases where the primary endpoint server goes offline, and two, it allows DLP agents to connect to alternate endpoint servers if the maximum number of agents are already connected to the primary endpoint server. The DLP agent for Windows can perform most detection methods locally on the endpoint computer. However, some of the more resource-intensive detection methods must be performed on endpoint servers to maintain the performance of users' computers and the organization's network. This approach is called two-tier detection. The types of detection rules that can be evaluated locally on the endpoint are DCM, described content matching, which are rules such as keywords, regular expressions, and data identifiers, EMDI, exact match data identifier validators, IDM, indexed document matching rules, and VML, vector machine learning rules. EDM, exact data matching rules, are evaluated on the endpoint server. Endpoint resource and bandwidth constraints make EDM impractical on the endpoint. Two-tier detection provides the best of both worlds: the ability to perform agent-based real-time blocking, quarantine and encryption actions, and exact matching on small to medium-sized data sources with DCM, EMDI, IDM, and VML, whether or not the agent is connected to an endpoint server, and the ability to perform server-based, highly accurate exact matching on very large data sources with EDM. Blocking, quarantine, and encryption actions, and on-screen user notifications need to be performed in real time, for instance when a user tries to copy a sensitive file to a USB device. Therefore, the only rules that blocking applies to are DCM, IDM, and VML rules, as well as any of these rules that include EMDI validators. Blocking at the endpoint does not work with EDM rules. If you try to use a combination of a block or a notify with any EDM rule, a warning will be displayed to remind you that this is not possible. Note that by default, the DLP agent evaluates IDM rules locally on the endpoint and performs exact file matching, that is, matching on a file's binary signature, and partial file content matching, that is, matching on discrete sections or passages of extracted and normalized file contents. It is also possible to configure two-tier IDM detection for the endpoint, where IDM rules are evaluated on the endpoint server to perform exact file content matching, or matching on 100% of extracted and normalized file contents. However, for performance reasons, Symantec recommends using local IDM matching methods on the endpoint rather than configuring two-tier IDM detection. This table summarizes the types of detection that are supported or not supported on Mac endpoints. DCM content and context detection is supported for data identifiers, keywords, regular expressions, file properties, user sender and recipient patterns, protocol signatures, destinations, devices, and protocols. EMDI matching is supported along with DGM directory group matching support, although limited to the sender user based on a directory server group rule within the user group based policies. IDM partial file content matching is supported in the following detection scenarios: where data is being moved to removable storage and network shares using save as operations, or when data is pasted to browsers or other configured applications. On Mac endpoints, VML and two-tier detection for EDM and IDM exact file content matching is not supported, along with DGM with the recipient based on a directory server group rule within user group-based policies. Symantec DLP agents can be installed on computers running any of the following operating systems: the 64-bit versions of Microsoft Windows Server 2008 or 2012 R2, either Enterprise or Standard, as well as the 2016 version of Windows Server, either Standard or Data Center. Microsoft Windows 7, either Enterprise Pro or Ultimate versions with Service Pack 1, both 32-bit and 64-bit versions. Microsoft Windows 8.1, either Enterprise or Pro and 64-bit, as well as Microsoft Windows 10 Enterprise or Pro, versions 1511, 1607, 1703, 1709, 1803, and 1809. Also supported are Apple Mac OS X versions 10.11, 10.12, 10.13, and 10.14. The Symantec DLP agent software reserves a minimum of 25 megabytes to 30 megabytes of memory on the endpoint computer, depending on the actual version of the software. The agent software temporarily consumes additional memory while it detects content or communicates with the endpoint server. After these tasks are complete, the memory usage will return to the previous minimum. The initial DLP agent installation consumes approximately 70 megabytes to 80 megabytes of hard disk space. The actual minimum amount required will depend on the size and number of policies deployed to the endpoint computer. Additional disk space is then required to temporarily store incident data on the endpoint computer until the agent sends that data to the endpoint server. Note that there is a default cap on the amount of disk space the agent can use, which is 5% of the total disk space. But the DLP administrator can change this limit on the Settings tab of the agent configuration. If the endpoint computer cannot connect to the endpoint server for an extended period of time, the agent will continue to consume additional disk space as new incidents are created. The disk space is freed only after the agent reconnects to the endpoint server and transfers the stored incidents. Note that system requirements for DLP are updated frequently. Please refer to the Symantec DLP System Requirements and Compatibility Guide for the most current information. To install the DLP agent on Windows or Mac endpoint computers, you must first create agent packages. These packages can also include the Information-Centric Tagging or ICT client for tagging sensitive endpoint files with classification metadata, as well as the Information-Centric Encryption or ICE utility for encrypting sensitive files on the endpoint. The packages can be manually installed on each computer or pushed to endpoints using deployment management software. Agent packages are created in the Enforce Server administration console at System, Agents, Agent Packaging. The packaging process creates a zip file that contains the agent installer, SSL certificate and keys, installation scripts, and optionally the ICT and ICE client and utilities. You generate a separate agent package for each endpoint platform where you want to deploy DLP agents. For instance, for Windows 64-bit endpoints, you can generate an agent installer win64.zip package. And for Mac 64-bit endpoints, you will generate an agent installer mac64.zip package. To create and install an agent package, copy the agent installation.zip files to the Enforce Server local file system. The files for the various supported platforms are as follows. For Windows 64-bit, look for agent installers x64.15.5.zip. Windows 32-bit will be agent installers x86.15.5.zip. For Mac, agent installers x86.64.15.5.zip. Next, in the Enforce Server Administration console, navigate to System, Agents, Agent Packaging. From the Select the Agent version drop-down list, select the version of agent installation software you are using to create the agent packages. For instance, to create agent packages based on the DLP 15.5 agent software, select version 15.1 and later. Under Select one or more agent installers, click the Browse button next to each platform you want to create a package for, then navigate to and select the appropriate agent installation.zip file. Next, specify other required parameters for the agent package, such as endpoint server host, tools password, and so forth. If you want to install the ICT client along with the DLP agent, first select Install the Symantec ICT client. Then, in the ICT web service URL field, specify the address of the web service on the ICT server in the format https ictserverfqdn/ict/webservice. Next, in the license field, paste the public server key value from the ICT server. You can find this value in the ICT administration console in the System Setup tab, Server Keys subtab, Base64 Public Server Key field. Next, if you want to install the ICE utility along with the DLP agent, select Install the Symantec ICE utility. Then generate the installer packages and deploy the appropriate agent package to each endpoint computer. For more detailed information on creating and installing agent packages, please refer to the Symantec DLP Administration Guide or the Symantec DLP Installation Guide. To monitor how confidential data is being used on endpoints after you have deployed the DLP agent, you must set up agent configurations in the Enforce Administration console. Among other things, agent configurations enable you to monitor the different vectors or channels across which endpoint computers transmit and receive data. This section will describe the endpoint channel monitoring categories. The Destinations option lets you monitor data transmitted from the endpoint computer to removable storage, CD/DVD, local drives, and printers or fax machines. Note that some of these options are supported for Windows only, and some are supported for Mac only. The clipboard options enable you to monitor copy and paste operations to and from monitored applications. You must confirm that the applications you want to monitor are either configured out of the box or have been added to the list at System, Agents, Global Application Monitoring in the Enforce Administration console. Both copy and paste operations are supported, but note that copy is supported for Windows only, and that some applications use paste operations that the endpoint user does not initiate, which may cause false positive incidents. Symantec advises that you test application behavior before you enable paste monitoring. The email option enables you to monitor Outlook and, on Windows machines, Lotus Notes. The web option enables you to monitor the following software and protocols: both Firefox and Chrome on both Windows and Mac machines, Internet Explorer and Edge on Windows machines, HTTP and FTP protocols on Windows, and Safari on Mac machines. Note that to monitor Chrome running on Windows endpoints in Metro mode, the Application File Access option must be enabled for the Google Chrome item in the Global Application Monitoring list found at System, Agents, Global Application Monitoring to work. Note, however, that if users will not be running Chrome in Metro mode, you should not enable the Application File Access option because selecting the Chrome HTTPS option in the agent configuration automatically enables application monitoring for Chrome. Consequently, manually enabling the Application File Access option for Google Chrome in the Global Application Monitoring list will result in duplicate incidents. Note also that to monitor Safari on Mac machines, the Symantec extension for Safari must be enabled on the Mac endpoint. The Mac endpoint user performs this step after the DLP agent has been installed on their computer. When the user opens Safari for the first time after agent installation, the Enable Symantec extension for Safari dialog will be displayed. The user must click OK in the dialog to enable the extension. If the user does not enable the extension at that time and closes the dialog, they will be reminded every 10 seconds to enable the extension. You can adjust the reminder interval by going to the Settings tab in the agent configuration assigned to Mac endpoints and modifying the Browser Extension Enablement Reminder value. You can configure what DLP agents monitor on endpoint computers and how they go about this task by creating and editing agent configurations in the Enforce Administration console, found at System, Agents, Agent Configuration. The agent configuration options determine the vectors or channels that are monitored on endpoints, and they enable you to set a variety of agent parameters, such as specifying monitoring filters and adjusting resource consumption limits. On the agent configuration page, you can click the default configuration to edit it, or click Add Configuration to create a new agent configuration. The Channels tab enables you to specify exactly what you want to monitor on the endpoint. By default, the only event that is configured for monitoring is removable media. The endpoint agent does not monitor any events that have not been enabled. In addition, within your DLP policies, you have the ability to apply policies only to certain events. Keep in mind that if the events are not enabled, the policy does not capture incidents over those applications or destinations. The location-based agent configuration settings feature enables you to set agent configurations for employees based on whether they are on or off the corporate network. For instance, agents can be configured to monitor network shares or web upload activity when users are working from home, but not when they are in the office. The definition of what your organization considers as on or off your corporate network can be configured at System, Agents, Endpoint Location. This feature is available for the settings on the Channels, Channel Filters, and Device Control tabs on the Agent Configuration page. Note that location-based agent configuration settings only work with version 15 and later endpoint agents. Versions 14.6 and older agents only apply on the corporate network configuration settings. Additionally, Mac agents only support this feature when the endpoint location is set to automatic. If the endpoint location is set to manual, all Mac agents are identified as off the corporate network. When you select the Application File Access option under Configured Applications, you are instructing Symantec DLP to monitor the activity of specific computer applications. A list of these applications is maintained on the Application Monitoring page, found at System, Agents, Application Monitoring. If you do not see the specific software you want to monitor, you can add it to the list by specifying such information as the file name of the application's executable, or the type of application it is, whether generic, CD/DVD, or cloud storage, and the activities you want to monitor, such as network access, file operations, etc. For the default applications included in the list, you can also configure global changes. You can associate blacklist or whitelist metadata to specific endpoint channels. You can also specify that you do not want Symantec DLP to monitor applications for network, printer fax, clipboard, or file system activities. For instance, you may want to exclude clipboard activities on Microsoft Outlook. To enact this change, edit the settings on the application fingerprinting page for Microsoft Outlook to exclude clipboard activity. On the Channel Filters tab, under the Filter by File Properties section, you can set file property filters to optimize monitoring. File property filters tell the agent to monitor or ignore files based on protocol, destination, file size, file type, or file path. Filters are run in the order they are displayed. A file is ignored or monitored based on the action of the first filter that it matches. You can change the order in which filters run by changing the numbers in the order column. Note that for filtering by file type on Mac endpoints, the DLP agent only considers the file extension, such as .txt, .docx, .pdf, and so on. It does not examine the file signature to determine true file type. For instance, if a user renamed a sample.txt file to sample.png, the DLP agent for Mac would identify the file's type as PNG, not as the true file type, a plaintext .txt file. Symantec DLP comes with pre-populated filters, and Symantec recommends that you do not delete them because appropriate filtering on the local drive and CD/DVD monitoring is essential to the system working properly. If you leave the Ignore filter blank for the local drive, you can eventually overwhelm the agent with the volume of files it needs to process. If you leave the Monitor filter blank for CD or DVD drives, you may not be able to open the burner application because all the files that are loaded may be blocked, even those needed for the burner application. Under the Filter by Network Properties section, you can whitelist sites based on their IP address or domain. For instance, you would probably not want to monitor your organization's internal wiki site, which is a trusted site and could create many false positive results. Note that using network property filters is classified as a pre-detection operation, as opposed to detection that occurs at the policy level. Therefore, it does not use additional processing resources during detection. In the IP filters and domain filters fields, enter filters based on IP addresses or domains that are accessible from the endpoint server and its associated agents. The filter syntax is the same as for network prevent filters. IP filters can be used for all endpoint-supported protocols, while the domain filters can only be used for the HTTP or HTTPS protocols. Under the Ignore User Identities for Cloud Storage Applications section, you can specify corporate cloud accounts that are approved for sensitive file uploads. Filtering by cloud storage user identity prevents users from uploading sensitive files to personal box accounts. The DLP agent monitors and prevents these types of file uploads through the Box Sync application and through the Box for Office add-in. Sensitive files are moved to the file recovery location and remain there until endpoint users delete them. To enable this feature, first, confirm that the cloud storage channel is selected under the Enable Monitoring section of the agent configuration. Second, enter the cloud storage accounts to ignore for monitoring. For instance, enter jimgreen@trustedpartner.com to ignore the Jim Green user account in the trustedpartner.com domain. You can enter an asterisk as a wildcard to specify a domain of cloud storage accounts to ignore. For example, enter *@example.com to ignore all cloud storage accounts with example.com in the domain. You can specify a set of printers that are approved for processing sensitive documents. The list can include local printers, PDF printers, and network printers. The DLP agent monitors and prevents information from being sent to any unauthorized printer. To enable this feature, enter the approved printer names in the Printer Filters field under the Filter by Printer Properties section. For multiple printers, add items as new lines and do not use commas. As with other filters in the Agent Configuration section, you can use the asterisk as a wildcard character to ignore a range of printers. On the Application Monitoring tab, you can specify different application monitoring settings than those that are configured under System, Agents, Global Application Monitoring, and that apply globally to all DLP agents. The settings that you specify on an agent configuration's Application Monitoring tab will override Global Application Monitoring settings and apply only to those agents to which that agent configuration is assigned. In preparation for assigning application monitoring overrides to specific agents, you need to create an agent group at System, Agents, Agent Groups, and then assign the relevant agents to that group. Creating agent groups will be covered more in detail later in this module. To configure application monitoring overrides, on the Application Monitoring tab, click Add Application and then select the platform that that application runs on, whether Windows or Mac. Then select the application whose global monitoring settings you want to override. To do this, in the Global Applications list box, select an application. Note that you can also type a name in the search field to quickly find the application. Then click Add to move the selected application to the Applications to Monitor Override Global Settings list box. Then click Save. Afterwards, in the Application table, click the pencil icon on the far right of the application's row to edit its monitoring settings. Adjust the application monitoring settings as needed, then click OK. Note that for comparison, the application's current global application monitoring settings are displayed below the override settings. To apply the application monitoring overrides to specific DLP agents, save the agent configuration and then assign it to the custom agent group you created for this purpose. The Device Control feature enables you to determine the general level of access that Windows Endpoint users have to USB devices, network shares, and print screen functionality. This feature leverages the location-based endpoint monitoring capabilities discussed earlier. For instance, DLP administrators can use device control to always block USB devices on endpoints, whether the computer is on or off the corporate network. Another possible use case is to allow full access to network shares when an endpoint computer is on the corporate network, but limit access to read-only when the system is off the corporate network. The device control feature has some limitations. 1. It does not support excluding specific devices or shares from being blocked or accessed as read-only. For instance, if you choose to block USB devices in an agent configuration, all USB devices will be blocked, without exception, on the endpoints to which the configuration is assigned. Secondly, it is not possible to assign device control options to DLP content or endpoint policies. Consequently, no endpoint incidents are generated for block or read-only device control actions. To configure device control, first, on the Device Control tab, do one of the following. If you are not using location-based monitoring, select the device control options as needed. If you are using location-based monitoring, select the option Enable different device controls for endpoints located on and off the corporate network, and then specify device control options as needed for both on-network and off-network conditions. Secondly, select the Block Print Screen option if you want to prevent users from copying their screens using the Print Screen key, or the Shift Print Screen key combination. Lastly, click Save. You can manage the impact that DLP agents have on network performance by configuring the maximum amount of bandwidth in either megabits or kilobits per second that an agent can use to upload data to and download data from the endpoint server during connection time. These settings are located on the Settings tab in the Server Communication section. The default setting of the consumption throttle is 5 megabits per second. To change the bandwidth throttle, select either megabits per second or kilobits per second, and then enter a number in the box for the maximum per second. If you leave a field empty, no throttling is applied for that direction of communication traffic. The inspection content size feature for detection servers that we discussed earlier in the module is also available for DLP agents on the Agent Configuration Settings tab. This setting enables you to quickly and easily increase an agent's inspection content size limit, which allows the agent to inspect files larger than the default 30 megabyte size limit. Although the ability to increase this limit was available in previous versions of Symantec DLP, it required the DLP administrator to manually adjust an assortment of advanced settings for the DLP agent. With the inspection content size setting, now you can just drag the slider control to the desired size, and Symantec DLP will automatically adjust the relevant advanced settings for you. You can click the Preview Updated Settings link to see which agent advanced settings would be modified and what their new values will be. The available inspection content size settings for DLP agents are 30 megabytes, the default, 50 megabytes, 100 megabytes, and 150 megabytes. You should be aware that inspection of larger files will take longer and require more memory for the inspection to complete. Also, timeout limits will increase, so the detection engine will take longer to time out in the event of detection failures. When the DLP agent is not connected to the endpoint server, the agent will temporarily store the incidents, two-tier detection requests, and the server response action requests locally on the endpoint host. You can limit how much disk space the agent store uses on the endpoint host by modifying the agent store size value in the resource consumption on the endpoint host section. You can specify a percentage of the hard drive or a specific amount of storage space in either bytes, kilobytes, megabytes, or gigabytes. If the agent store size limit is exceeded, the DLP agent will delete data from the endpoint host according to a set priority until the agent store size limit is met. If the DLP agent must delete incidents, the order of detection is as follows: two-tier detection request data, oldest first, endpoint discover incidents, oldest first, and regular endpoint incidents, oldest first. Because Symantec DLP endpoint servers and agents communicate by standard HTTP over SSL, the communication architecture is reliable and scalable, as well as friendly to load balancers and firewalls. On the Advanced Settings tab shown in this screenshot, there are 3 settings that give you full control over the agent-to-server connection interval, which can range from a persistent connection to a transient check-in interval. Such flexible configuration options enable you to strike the required balance between scalability and communication frequency. The relevant settings are, first, endpoint communications.heartbeatintervalinseconds.int. This is the agent heartbeat setting that controls how often the endpoint server will send heartbeat messages to detect dead connections to individual agents when no other traffic is being sent or received. Change this setting to be less than the load balancer's close idle connection setting. If you do increase the agent heartbeat setting, you must also increase the comlayer.notraffictimeoutseconds.int setting to a value greater than the agent heartbeat setting. Lastly, the endpoint communications.idletimeoutinseconds.int setting specifies the maximum time to keep an idle connection open. The connection is closed when the specified number of seconds has passed. The timeout only applies during the normal operation phase of a connection, which occurs after the SSL handshake and application handshake phases. Change this setting to be less than the load balancer's close idle connection setting. In the event the DLP agent loses its connection with the endpoint server, it backs off from attempting to reconnect for the amount of time set in the initial connect back-off duration second setting, which is 30 seconds by default. If after the initial back-off time the agent is still unable to connect to the primary endpoint server, it backs off again using the initial backup value multiplied by the value set in the connect back-off duration multiplier setting, which is 2 by default. This means that the agent now backs off for 60 seconds. The multiplier is used for each subsequent unsuccessful attempt. Using the default multiplier of 2, the subsequent backoff times in seconds would then be 60, 120, 240, 480, and so on, until the value in the max connect backoff duration seconds setting is met, which is 1800 seconds, or 30 minutes, by default. If the DLP agent connects to a secondary endpoint server, the backoff strategy is not applied because it does not work for secondary servers. After attempting to connect to a second endpoint server, the agent will attempt to connect to a third endpoint server if available. During backoff, if there is change in network connectivity so that the connection is either restored or a new network is available, the agent immediately tries to connect to the primary endpoint server and begin the backoff strategy again. Agent groups enable you to group and configure agents according to user-specific or machine-specific characteristics, such as country, location, or department name. These characteristics are called agent attributes. You can use attributes to create groups and assign specific configurations to the groups based on your business needs. Some possible business use cases for agent groups are 1. Excluding specific countries from endpoint monitoring, 2. Rolling out DLP agent configuration changes in large organizations, 3. Using multiple endpoint servers to deploy agent configurations, or 4. Modifying agent configurations or isolating agents with problems. Using agent groups involves several tasks and steps, from defining the attributes and groups and applying the changes to resolving group conflicts. The steps shown in this figure provide an overview of how the agent group process works. 1. The admin defines agent group by definition, attribute query, and agent configuration. 2. The agent group info goes to the endpoint server, where the endpoint server holds the agent group info in RAM. Next, the query goes to the DLP agent, where the agent stores the query and executes it against Active Directory. The agent will then store the query results and send them to endpoint server. After receiving it, endpoint server assigns the agent to a group, deploys the agent configuration, and sends the agent group assignment to Enforce. Lastly, Enforce will write the agent group info to the database. You can define several different agent group types from the System, Agents, Agent Groups page in the Enforce Administration console. Agent groups can be based on agent attributes, endpoint server name, or endpoint host name. The predefined agent attributes are agent host domain, agent host type, agent host version, logged in user, and logged in user domain. You can create new agent attributes by clicking Manage Agent Attributes on the Agent Groups page and clicking New. For details on how to create new agent attributes, refer to the online help in the Enforce Administration console or in the Symantec DLP Administration Guide. To create an agent group, on the Agent Groups page, click New. Then specify the details for the agent group, such as what the group is based on, whether user attributes or endpoint server, as well as the agent attributes. At a minimum, you can create an agent group by simply specifying a name for the group and entering the host names of DLP agents in the Always Include These Agents field. To deploy a new or updated agent group, you must assign an agent configuration to the group. On the Agent Groups page, select the agent group to which you want to assign an agent configuration. Then click Assign Configuration. Choose an agent configuration from the Assign Configuration dialog box, then click OK. Note that to avoid confusion with the endpoint device control and location-based agent configuration settings features discussed earlier in this lesson, here are a couple points to keep in mind as you study this section. The endpoint devices configuration described in this section is completely separate from the device control feature used in agent configurations. Agent configuration device control enables you to block or allow read-only access to all USB devices or network shares across the board. This is not content-aware and it does not generate incidents. The endpoint devices configuration, on the other hand, is used with the endpoint device class or ID detection rule and matching condition that can be added to DLP policies, enabling you to generate incidents and target response rules to specific devices. The endpoint location configuration described in this section is a prerequisite for using location-based agent configuration settings, but its uses are not confined to agent configurations. The endpoint location configuration is also used with the endpoint location detection rule and matching condition that can be added to DLP policies. You can monitor endpoint activity based on the described device metadata of devices, for instance, external storage devices, that are connected to endpoint computers, and also by the location of endpoint in relation to your organization's network, that is, on or off the network. These items are configured at the following locations: endpoint devices at System, Agents, Endpoint Devices. Endpoint location at System, Agents, Endpoint Location. For endpoint devices, the device instance IDs must conform to regular expression syntax. In Windows, you can find device instance ID metadata in Device Manager by viewing the endpoint device's properties, and on the Details tab, selecting Device Instance Path from the drop-down list. For instance, the device instance ID for a generic USB device in Windows might look like the example shown in this slide under the device definition field. For endpoint location, there are two methods for determining whether an endpoint device is on or off the network: automatic and manual. With the automatic method, Symantec DLP identifies the endpoint as being on the network if the DLP agent is able to communicate with an endpoint server, and conversely, as not being on the network if the DLP agent is unable to communicate with an endpoint server. With the manual method, you must input a range of domain names or IP addresses, and then Symantec DLP uses this information to determine if the endpoint is connected to the network. When Symantec DLP detects confidential data in use on endpoint computers that violate policy, it captures incidents, which contain details about the occurrence. Incidents can be viewed in the Enforce Administration console at Incidents, Endpoint. The most recent incidents are listed in the Incidents New report. To view incident snapshot details, click on an incident in the report. Here are some of the details specific to endpoint data in use incidents. The type of incident is the endpoint monitoring channel on which the incident occurred. In the example incident shown in this figure, the incident occurred when the user attempted to copy a confidential file from a network share to their local drive. This action was detected because the Copy to Local Drive option was selected on the Channels tab in the agent configuration. The user field represents the name of the user logged into the endpoint when the incident occurred. It's in the format domain/username. The machine name lists the name of the endpoint computer where the incident occurred. The machine IP lists the IP address of the violating endpoint computer if the computer was on the corporate network. The endpoint location indicates whether or not the endpoint was connected to the corporate network at the time the incident occurred. The application field lists the name of the application that caused the incident. File name lists the name of the file that violated the policy. The file name field appears only for fixed drive incidents. The destination field lists the destination location or file path for the confidential data. The device instanced ID field lists the ID string of the endpoint device that caused the incident. For instance, the local device to which the confidential data was copied. Access information is the available ACL information for the file that caused the incident. This is only applicable to endpoint discover and endpoint local drive monitoring. In summary, Symantec DLP Endpoint communicates with an agent installed on endpoint computers to help organizations monitor and establish a baseline for what users are doing with confidential data on their devices. Most detection methods are performed directly on the endpoint computer by the DLP agent, but resource-intensive detection methods, such as EDM, exact data matching, use two-tier detection, where endpoint servers will handle the detection work in order to maintain the performance of users' computers and the organization's network. Note that OCR is not available for endpoint detection at either the agent or the server level. Agent configurations enable monitoring of the different vectors or channels across which endpoint computers transmit and receive data. The endpoint channel monitoring categories are destinations, such as removable storage, CD or DVD drives, local drives, printers, and fax machines. Clipboard, meaning copy and paste operations to and from monitored applications. Email, which can include Outlook and Lotus Notes. Web, which includes HTTP, FTP, HTTPS on Internet Explorer, Edge, Firefox, Chrome, and Safari. Configured applications, application file access and cloud storage. Network storage, which affects copying to local drives and copying to shares. And SEP intensive protection, an integration point with Symantec Endpoint Protection that provides the DLP agent with application reputation information so it can monitor applications and prevent potentially harmful software from accessing sensitive files on the endpoint. Incidents for sensitive endpoint data can be viewed in the Enforce Administration Console at Incidents Endpoint. In this module, we discussed establishing a baseline for how confidential data is being used in an organization, a crucial phase in establishing a successful data loss risk reduction program. The baseline helps organizations understand what actions they need to take, such as training employees about data security or addressing broken business processes, as well as how to fine-tune DLP policies to make them as effective as possible. We also examined how the following Symantec DLP technologies can be used to establish the baseline. Network Monitor monitors SMTP, FTP, HTTP, and popular IM services. It also lets you monitor custom protocols and specify IP and L7 filters to filter out low-risk traffic. Network Prevent for Web monitors web traffic, such as HTTP, HTTPS, and FTP. Network Prevent for Email monitors SMTP email traffic. Cloud Service for Email monitors outbound email from Microsoft Office 365 and Google G Suite Gmail. Endpoint uses an agent installed on employees' laptop and desktop computers to monitor how data is being used on the endpoint. It monitors such activities as copying to USB drives, burning to CD or DVD, transferring data to or from mobile devices, downloading to local drives, printing and faxing, copying to network shares, and encrypting or concealing data using high-risk applications. For more information on the topics contained in this module, please reference the Symantec Data Loss Prevention Administration Guide, the System Requirements and Compatibility Guide, the MTA Integration Guide for Network Prevent for Email, or the Symantec Data Loss Prevention Installation Guide, as well as the general help and knowledge base found at the support.symantec.com website. Thank you for joining us. This concludes the Understanding How Confidential Data is Being Used module of the Symantec Data Loss Prevention 15.5 Administration course.